Our last example in 6.1 is definitely the most complicated. Here we're going to have another plane flying on a certain bearing, but now we're going to have wind affecting us a little bit. And to kind of model for you what this might look like or what we're going to visualize, let me show you something in Sketchpad here. So here is a vector that represents our plane, and I'm giving you the component form up on top here. So you don't know the speed here, we just know what the final component form is, how far to the east, how far north in this case that it's going. But let's say that besides just the plane, there is wind. Okay, so maybe the wind is going off whatever its bearing and magnitude are, it gives us this component form. If the wind and the plane are kind of working together, you would expect the plane to go a little bit faster and end up going a little bit further in the end. And in general, we put these two things together through the idea of vector addition. So this is kind of going way back to one of the first videos that you probably watched here with how addition works. If the wind, let me get rid of this part here, but if the wind went backwards, you can see that the plane, if they're pushing against each other, the plane's not going to go as far. And again, it's basically connected through a vector addition. So that's what you need to be thinking about in this problem that we're going to be looking at. Okay, so we have a 727. It's leaving San Francisco. It's on a bearing of 124 degrees, the ground speed of 505 miles per hour. 65 mile per hour wind with a bearing of 60 degrees. Determine what the plane's actual ground speed and compass headings are. So what we're trying to do, going back to Sketchpad here, if there's the wind, there we go, something like that. We're trying to figure out this black vector, what its magnitude is and what its bearing is, what the combined versions are. Okay? So a lot to go through here. First we'll start with drawing a bit of a picture. Get a little bit more space there. So we are going to, we can use red, that's fine. Okay, start off with our picture. We have our plane going on a bearing of 124 degrees. So again, you have to think bearing, starting from north and going this way, 124 degrees would get us somewhere there. Okay, this is not going to be too much to scale here. I'm just warning you ahead of time. But I'm going to have to get a math angle from this. That math angle is going to be measured from starting at this direction. Now we could certainly go all the way around. I think it might be easier to go down from here, and that's going to be an angle of 34 degrees. But for the math part of it, I'd have to count it as a negative angle. Okay, so this is negative 34 degrees there. And I also know the speed. The speed was 505, so that's the magnitude. Okay, now for the wind, it was on a bearing of, let's see here, a bearing of 60 degrees, and it went a distance or a magnitude of 65. So 60 degrees is maybe, for a bearing, is a little bit more like that. This was 60 right there, which means the math angle that I would need to use is 30 right there, right? You have to add up to 90. And the length here was 65. So that 65 is the length of the arrow. Try to keep all of that together if you can. So we need to come up with some different vectors. The wind might be the easiest one here, so we'll say, if I'm going to label a few things here, let me go to black a second. This is going to be A for the airport, we'll say. This is going to be point P for the plane. This will be W for the wind. And then, if I took this purple vector here and kind of added it right here, again, I'm not saying that this is too much to scale, but, through vector addition, I might end up right there. The vector that I want to find goes like that, and we'll say that this is F for the final position. Okay, so that's kind of the picture that we'll be looking at. I know it's looking kind of complicated, but hopefully that does make sense overall. Oh boy, not this guy. Okay, we'll let him kind of pass here a second. Okay, so that is gone. Let's go through and come up with some of our vector information here. So to start off, how do we find the vector AW that represents the wind? Okay, that is going to get me the magnitude of 65 times cosine of 30. Okay, and then the magnitude of 65 times sine of 30. Okay, just squeezed it in there. Go ahead and calculate that out. I would get 56.29 comma and then 32.5. Okay, so this is one big vector that I need to know what represents the wind. Okay, I also need to figure out a vector that would represent the plane. So that's going to be AP. Okay, that was a speed of 505. Okay, so that's my magnitude there. Times cosine of the angle. Remember, my angle measure was negative 34 degrees for the math part of it, comma. And then 505, and I think I can squeeze it in there, times sine of negative 34. And if we can, fit in that final vector symbol there. Okay, this one, I think I actually need to calculate it out really quick on my calculator, so bear with me. I might even pause things here a second. Okay, and when I calculate that out, I get 418.66 and negative 282.39. Now, visually looking at our map, the blue vector and the purple vector, that seems to make sense. And so what I want to do now is add those two vectors together to get the final vector for this plane. So vector AF will equal AW plus AP. There's a P there. Okay. Okay, so if I add those together, I can do those on my calculator. I get 56.29 plus 418.66. Okay, for the X, I get 474.95. Okay, and then for the Y value, I do 32.5 plus a negative 282.39. Okay, and that gets me negative 249.89. Okay, so we have a lot of our different measurements there. Our goal now is to, from that final vector that I have in black here, which looks kind of sloppy there, but that vector right there, from that, can I figure out the angle measure and the bearing, I guess, and the speed of the plane. So I'm going to pause the video here, and we'll start a new one to finish this up.